2.1 Alex Lee's cardiovascular responses. This is just an introduction to the CV system, but I'll explain it in more depth later on. The cardiovascular system consists of the heart, which is an anatomical pump, with blood vessels, arteries, veins, venules, arterioles, and capillaries that traverse around the whole human body, carrying blood to and from it. The blood is transported through the whole body by a continuum of blood vessels. The heart's job is to pump blood. That's it, just pump blood. Blood contains oxygen and other nutrients which your body needs to survive. The body takes these essential nutrients from the blood at the same time from the body and dumps waste products like carbon dioxide back into the blood so they can be removed. The main function of the cardiovascular system is to therefore maintain blood flow to all parts of the body to allow the body and humans to survive. Cardiac dynamics. In the equation, Q equals HR times SV. Q specifically refers to the amount of blood pumped out of the left ventricle in 1 minute. Cardiac output is made up of two components, heart rate and stroke volume. Heart rate refers to the number of times the heart beats every minute, beats per minute. This can be easily measured through the use of heart rate monitors or taking a person's pulse. Heart rate increases as the intensity of the activity increases. This is shown because the working muscles demand more energy, so the heart beats increasingly faster in order to deliver the nutrients and oxygen needed to meet these increased energy demands. Stroke volume refers to the quantity of blood pumped out of the left ventricle with every beat. The exact volumes are not easily measured, so they are often estimated based on what we know about stroke volume. The normal resting heart rate for adults is between 60 and 100 beats per minute. Highly trained athletes will have a resting heart rate below 60 beats per minute, sometimes reaching 40. Submaximal exercising is around 100 to 170 beats per minute. This is for adults who do exercise regularly, but for highly trained athletes, this will be around 100 to 150. Maximal exercise would just be your from anything just to your maximum heart rate, which would be 220 minus your age. The ANS, or the autonomic nervous system, takes control of all of the unconscious factors that might happen, like breathing while sleeping, to your heart rate. The CCC, or the cardiac control center, is what controls your heart rate. It can speed it up or slow it down when necessary. There are two different branches that are used in the autonomic nervous system. These are called the sympathetic and the parasympathetic nerves. The parasympathetic nerve is a nerve that slows down or inhibits such a thing, reducing the heart rate and constricting the bronchi. The sympathetic nerve, however, accelerates things, such as your heart rate, or dilates your bronchi. There are many functions for both sympathetic and parasympathetic. For example, the sympathetic accelerator nerve will increase the strength of contraction, whereas the parasympathetic vagus nerve will decrease the strength of contraction. Another function for the parasympathetic nerve will vasoconstrict the arteries travelling to the heart and muscles to allow less blood to flow to those areas. Receptors in the blood monitor everything going on around us. There are three different types of receptors. There are chemoreceptors, proprioceptors, and thermoreceptors, but the one that links in with the cardiac cycle is the chemoreceptors. These receptors will monitor the chemical changes in the blood. This information will be sent back to the cardiac control center, and that will decide what to do with it. Adrenaline is also released from adrenal glands. This will affect the SA node in that it will increase your heart rate. Hormones have the ability to affect the heart rate. One example would be be adrenaline. This is released from the adrenal glands. This hormone can be released into the bloodstream when a person encounters a stressful situation. This is known as a fight or flight response. The release of adrenaline can result into a number of effects. One of the main effects that is an increase of heart rate. The parasympathetic input to the heart is through the vagus nerve. When stimulated, acetylcholine or ACH binds onto the receptors, which acts to decrease the pacemaker potential, leading to a decrease in heart rate. The sympathetic nerve is via the fibers from the sympathetic trunk, which innervate the SA node and the AV node. These fibers release noradrenaline, which acts on receptors to increase the pacemaker potential. When your heart beats, it pumps blood around your body. As the blood moves, it pushes against the side of the blood vessels. The strength of this pushing is your blood pressure. If your blood pressure is too high, it puts an extra strain on your arteries and your heart, and this may lead to heart attacks and strokes. Blood pressure is measured of the force being exerted on the walls of the arteries as blood is pumped out of the heart. Blood pressure measurements are usually taken on the upper arm with a sphygmomanometer. I probably butchered that, but anyway. Blood pressure is measured in millimeters of mercury, mmHg, and is given as two figures: systolic pressure, which is the pressure of your heart, which is the pressure when your heart pushes blood out, and diastolic pressure, which is pressure when your heart rests between beats. The ideal blood pressure is 120/80. If your blood pressure starts to increase, you will go to prehypertension, which is 120 to 139/80, 80 to 89. This is worrying as it could lead to high blood pressure. High blood pressure is often related to unhealthy lifestyle habits such as smoking, drinking too much alcohol, being overweight, and not exercising enough. There are 3 different stages to hypertension. Stage 1, which is 120 to 59, and 90 to 99. Stage 2 is 160 or higher, over 100 or higher. If it gets to this stage, it is really bad. But if it gets to stage 3, which is higher than 180 over higher than 110, which is higher than 110, if high blood pressure is left untreated, high blood pressure can increase your risk of developing a number of serious long-term health conditions such as CHD or coronary heart disease and kidney disease. Low blood pressure or hypotension is less common but is not as bad as high blood pressure. It can also be caused by a number of conditions such as heart failure and dehydration. Some of the effects of low blood pressure are dizziness and fainting. In severe cases, low blood pressure can be life-threatening. There are stark contrasts in blood pressure of vessels in different sizes. For example, blood pressure in capillaries is usually about 20 to 30 millimeters of mercury, whereas the pressure in large veins may become negative. This would be lower than the atmospheric pressure. The heart must beat faster during exercise because by increasing the heart rate, the body is able to increase cardiac output and deliver the necessary blood flow to the muscles. During exercise, the body's muscles increase their activity level and consume more oxygen. Increased blood flow delivery is necessary to allow for this increased demand. The heart rate during the multi-stage fitness test is a prime example of this. At rest it is around 62 beats per minute. This increases to 82 beats per minute due to anticipatory rise coming into play. The anticipatory rise is the mind's response to the body's need to prepare for exercise. As the multi-stage fitness test went on, there was a sudden increase from the pre-test to L2, where it increased to 150 beats per minute. It then slowly increases over time from L4 to the post-test, where it reached 159 beats per minute. The person was working at submaximal, working submaximally, since their heart rate is 204. So this person could have worked harder for the test results. The Wingate produced similar results in the way that the resting levels were a lot lower than the post-test results. But what was interesting is that in different timescales, the multi-stage fitness test lasts for around 20 minutes, whereas the Wingate only lasts for 20 seconds. This is interesting because it shows how maximal the Wingate is and how intense it is compared to the multi-stage fitness test. At rest, the Wingate is 81 beats per minute, which is not very good for a resting heart rate. Tachycardia refers to a high resting heart rate. When an individual has tachycardia, the upper or lower chambers of the heart beat significantly faster. When the heart beats too rapidly, it pumps less blood efficiently around the body to the rest of the body. This includes the heart itself. The pretest is where the anticipatory rise happens. I explained this in the paragraph above. The post-test is the same as the multi-stage fitness test because they both have extremely high heart rates at the end due to the body needing more blood to go to the working muscles. The Wingate test is maximal, is a maximal anaerobic activity because it lasts for under a minute and you only go up to the lactic acid system rather than using the aerobic system like the multi-stage fitness test. There are many different types of situations where different types of heart rate will fluctuate very differently. Low heart rate will be the most common occurrence in football, in the fact that you are likely to find it in any situation. In the example I have given is a person jockeying the player. The reason this is low because it's slightly raised heart rate, as you are not doing very strenuous exercise that will rapidly increase your heart rate like a throw-in. A throw-in is a good example of moderate heart rate, as you are sprinting in a very short period of time. This would be moderate as you are sprinting and then possibly running at a light speed to get back into position. High heart rate would happen when you get past the ball and run down the line at high speed. This would be high heart rate since you were doing it for a prolonged period of time rather than for a very short period of time. That is the cardiovascular system.